Continuing on with our straight lines topic, we've also got a new special kinds of lines to consider, and that is parallel lines and perpendicular lines. We may have been referenced to some of these lines before, but we may not have, so let's just start from the beginning. If two lines are parallel, it means that they never intersect. Well, this is because they are always changing at the same rate. At the same rate. Okay, if I have two straight lines, so let's just, don't have to copy this down, but if I have a ruler and I have a straight line, I've got this straight line, it's going. And then I have this straight line there, it's also going. They're never going to intersect because they're always changing at that same rate. They're always at that same direction. Well, what else does that maybe look like? They have the same steepness. They rise and they run at the same rate. Since they have the same rate, we know yesterday that we can equate that. We can therefore say that parallel lines have the same gradient. Parallel lines will have the same gradient. Perpendicular lines always meet at 90 degrees to each other. So if two lines are perpendicular, it means that they intersect at 90 degrees. Think of the corners of a wall, one corner and another corner. Those lines intersect and there's a right angle. So perpendicular lines intersect at 90 degrees to each other. If two lines are perpendicular, then their gradients multiply to give -1. And now that's just a bit of a different rule, okay, but we will get into that a little bit today, so don't get too freaked out about it all. And now I want to copy my graph into here, so bear with me. Okay, there we go. Actually, no, I want it a bit bigger. Perfect. So, two parallel lines will have the same gradient. If two lines are parallel, they share the same gradient. The gradients of two perpendicular lines multiply to give -1. And now let's say we want to find the equations of these lines, and say let's find the equation of a line parallel to this line at this point. Well, we can figure out the equations of our lines. Equations of our lines can be found. Equations of our lines can be found by finding the gradient and substituting in a point. Finding the gradient and substituting in a point. And we'll go through a few examples of that later where we do that exact process, okay? And just on my graph now, I'm going to draw some examples of parallel and perpendicular lines, okay? Now, easy enough with my ruler, I can just draw along like this, and these lines are parallel because they don't intersect. So they're parallel lines. They're never going to intersect. They're going in that same direction. But then I've got perpendicular lines, and I could say, okay, well, let's have one line. We're going to look something like that. And now my new one, that looks about right, is going to be here. Okay. And they will always meet at 90 degrees. So the parallel lines are in red and they're never going to intersect. They always have the same gradient. But the perpendicular lines there in blue, if you find their gradients, they're going to multiply and they're going to give you -1. So example. Determine if the following lines are either parallel or perpendicular. So we're just going to be looking at the gradients of these lines to tell right now. So my first pair of lines, let's say we've got y is equal to 4x plus 2 and y is equal to 4x take 6. Now, all I want to first do is I want to talk about the gradients of these lines. The gradients are the important part. So the first gradient, what's the gradient of the line 1? Well, it's that m in front of my x, so it's 4. The gradient of line 2 is also 4. Well, since they have the same gradients, we know that these two lines, they're parallel. These two lines are parallel. Well, what about another one? Let's say I've got y equals 3x take 1 and y equals -1/3 x plus 4. Again, let's pick the gradient straight away. So the gradient of line 1, that's just equal to 3. The gradient of line 2, that's -1/3. So they're not equal to each other. So we know right now they're not parallel. They're not parallel, but they could be perpendicular. We don't know right now, so we have to try and check with our test. So m1 times m2, that's going to be 3 times -1/3, which equals -1. Well, since they multiply to give -1, they are perpendicular. Since the gradients multiply to give -1, they are perpendicular. Find the equation of a line that passes through 0, -1, So it intersects at this point, it has that point on the line, and is perpendicular to a line with gradient of 2. So we want to find the equation of a line that passes through the point 0, -1, and is perpendicular to a line with a gradient of 2. Okay? Now, what this means is we first need to find the gradient of the perpendicular line. So if the gradient of our line 1 is 2, well, the perpendicular, that's the sign for perpendicular. I'll just write that out, that's perpendicular. The perpendicular gradient is going to be -1/2. Okay? If two lines are perpendicular, then they multiply to give -1. So really I could write it as 2x equals -1, so x equals -1/2, which is how I got this here. Since I know my gradient, I can write my gradient intercept form as -1/2x plus c. I don't know the value of c yet, okay? This is where I need to plug in my point, which is this point here. And I put that into my equation. Now remember, it has coordinates x, y. So x is going to be 0 and y is going to be -1. So -1 is equal to -1/2 times 0 plus c. Well, -1/2 times 0 is just 0, so -1 is equal to c. And then I'm going to put that back into my first equation. So therefore, the equation of the line is y equals -1/2x take 1. Or you could also write it as y equals -x/2 take 1. Both of those would give you full marks. They're both absolutely fine, but it just depends on what you prefer to write. Find the equation of the line. Find the equation of the line parallel to y equals -2x take 7 and passes through (1, 9). Now we're all probably looking at this and going, whoa, 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 there are way too much information in this question. Well, really, it's the exact same information as the first question, but it's written a little bit differently. So the equation of the line parallel to y equals -2x take 7 and passes through 1, 9. Well, we know straight away m1 equals -2. This line is written in gradient intercept form, and so I can write it as the gradient is -2. Well, if my line is parallel, I'm going to write 2 lines there, and that is the symbol for parallel, 2 straight lines. The parallel gradient is also -2, because if 2 lines are parallel, they have the same gradient. So a parallel line has the equation of y equals -2x plus c. Again, I don't know the value of c, but I do know it passes through this point here. So I put this point, I substitute these values into my line, okay? So my y value is going to be 9, so 9 is equal to -2 times the x value is 1 plus c. 9 equals negative 2 plus c. Negative 2 times 1 is just negative 2. And then 11 equals c. Put that back into my first line. So my final equation is going to be that y equals negative 2x plus 11. Now hopefully that gives you guys a bit of an idea onto how we're going to be performing this operations with parallel and perpendicular lines, and give it a go. The questions are there at the top.